Okay, so it says find KSP. So now we're looking for KSP. They gave you X. So this is a little different from the last problem. We're going to set up our ice chart first, as usual. And the class just told us the first column, you're going to cancel it out because it's a solid. All right, so that makes KSP problems a little bit easier than the other ones. All right, next up. What do we have for these two? The initial for the products. It's going to be 0. Awesome. Good. What about this one? Plus 2x. Awesome. Plus 2x. All right, the 2 comes from the coefficient. The plus is because it's a product. We're making it, which is awesome. What about the next one? Plus 3x. All right. And then for the last column, we're just bringing it down, right? So this is going to be 0 plus 2x is just 2x. 0 plus 3x is 3x. We have an ice chart, right? All right, KSP. What is KSP going to equal? What's going to be our first thing in brackets? Andrew, what do you think?
BI plus 3 squared.
All right. BI plus 3 squared. Perfect. And then the second one. Cameron, what do you think?
S minus 2 cubed.
Perfect. Yep, S minus 2 cubed. All right, so there we have our KSP equation set up. Okay, can we substitute anything in here? Kara, what do you think? Yeah, we can do. What do you want to substitute? Let's just change it into the x's first. Yeah, what were you going to say? Oh, I see. You're going to solve everything. No, let's just plug these things in first.
2x squared.
There we go. Yeah, you're going too far ahead, which is great. And then what's the next one? 3x cubed. All right. So we have 2x, the quantity squared, 3x, the quantity cubed. Now, you can do this a few different ways, all right? You can simplify and then combine the whole thing and plug in x at the end, or you can just plug in x here and here. It doesn't make a difference. You get the same answer, all right? So I'm going to kind of do a combination of simplifying and then plugging it in. First thing I'm going to do is I'm going to do the distribution of the 2 and the 3. Okay, so what's 2 squared? 4. And then what's x? Sorry, this is 4x. There we go, right? To the second power. What about 3 cubed? What's 3 cubed? 27. A lot of people want to say 9 though, right? But it's 27 because it's 3 times 3, which is 9, times another 3, which is 27. All right? So we have 27x, that's not a 27, it's a 2. 27x to the third. And then you can actually combine this again and make it 108, I think it is, or something like that. 108x to the 5th power, and then plug in the x if you want to. Or you can plug in the x's here. It doesn't make a difference. You'll get the same answer. All right. So let's combine it. KSP. All right. So 4 times 27. I think that is 108, right? 108. Somebody check that. 108, and then the x's, because we're combining them, it's going to be x to the 5th. Right there. Now, we know what x is because it's given up here. So we can plug this in for that x that's right there. And this is where it gets a little bit tricky with the calculator. So we have 1 times 10 to the negative 15. And we have to raise that whole thing to the 5th power. And you do that first, and then you multiply it by the 108. It's like the order of operations kind of a thing here. So what I would do is I would put parentheses 1 times 10 to the negative 15 close the parentheses and raise that to the 5th power, which is going to give you 1 times 10 to the negative 75th. All right, so calculator-wise here, I'll write what I'm doing on the calculator. I would do 1, oops, that's not the calculator. This is the E button. 1e negative 15. All right, 1e negative 15, that's going to give you 1 times 10 to the negative 75th. And then what I would do is multiply 108 times 1 times 10 to the negative 75th. You can probably do it all together, but again, order of operations gets a little weird in here sometimes. My goal is to make it as straightforward as possible. Your goal is to come up with the KSP being 1.08 times 10 to the negative 73rd. Okay, now let's talk about what does this mean. Remember, K. If K is greater than 1, if K is less than 1, that means something, right? So if K is greater than 1, that means you're going to have more products. If K is less than 1, you're going to have more reactants. The larger K is, the more products you have. The smaller K is, the less products you have, or the more reactants you have. So another way of looking at this is, you see how small this number is? Like times 10 to the negative 73rd? That's really small. That's like almost as far away from 0 as you can get when we're talking about using our calculators, right? Because we can only go to the negative 99th power. So that's really, really tiny. What that means is this is not very soluble, which means you're going to have more reactants. Which again means if you were to put this in water, it wouldn't really dissolve. Some of it would come out and dissolve and float around. But if we were looking at this in a beaker, most of it would be at the bottom here, staying together as the bismuth sulfide solid. So that's 2, that's a 3. And occasionally you would see a bismuth floating around. And occasionally you'd see some sulfide floating around, but it would be a very, very small amount of it. And if you remember a couple chapters ago, we talked about looking at a chart and seeing if something was soluble or insoluble. This would be an example of something that's insoluble, that it doesn't really dissolve in water. And so it would just sink to the bottom. Even though it's insoluble, some particles still will float out of it and kind of be in the water. So even the insoluble things still kind of float around. Okay, any questions with how we did that problem? Did we solve the problem? We were looking for KSP. We found KSP. Awesome.